In this video, I'm going to show you some background information about ductile and shear damage in Abaqus that we're going to use in this section. This one is going to be a ductile damage. So the ductile damage initiation criteria is a model for predicting the onset of the damage due to a nucleation, growth, and coalescence of void in a ductile metal. The model assumed that the equivalent plastic strain at the onset of the damage is a function of the stress triaxiality and a strain rate. So as you can see here, what we need to provide a fracture strain, a stress triaxiality, and we need to provide a strain rate. The temperature is optional, so if you have a data temperature dependent, you can activate this one and add a temperature here as well. And also from the sub options section, we can add a damage evaluation. So simply, this is a formula that if we satisfy this formula, the damage is going to initiate, and the following condition should be satisfied for the damage initiation, which is this formula, and where WD is the state variable that increases monotonically with a plastic deformation. So the first damage model we're going to use is a ductile damage. The second one is going to be a shear damage. The shear damage initiation criteria is a model for predicting the onset of the damage due to a shear band localization. The model assumes that the equivalent plastic strain at the onset of the damage is a function of the shear stress ratio and a strain rate. So we have a fracture strain, we have the shear stress ratio, and also we have a strain rate. And here we can activate a use temperature dependent also to add the temperature. And also from a sub option, we can add the damage evaluation parameters based on the displacement or based on energy. So here the shear stress ratio is defined as this formula, where the Q is the von Mises equivalent stress, Ks is the material parameter that for different material this value is gonna vary. For instance, for aluminium is 0.3, and P is the pressure stress, and T max is the maximum shear stress, and also a strain rate that we show it with the epsilon PL. So the criterion for damage initiation is met when the following condition is satisfied. That we have a WS, and this is the formula that we have at the top, and where the WS is the state variable that increases monotonically with a plastic deformation proportional to the incremental change in the equivalent plastic strain. So if you provide these two information, ductile damage and shear damage, you would be able to see the damage in the metal like parts, like whatever it could be.